Hello everyone. Today we're going to be solving AQA GCSE Chemistry Foundation Tier Paper 2, June 2020. This is a part 2 of the question paper where we're going to be solving from question number 6 to question number 10. This question is about materials used to make plates. Plates are made from ceramics, paper, or polypropylene. Paper plates are biodegradable and recyclable. Which stage of life cycle assessment LCA would contain this information? Disposal at the end of useful life, extracting and processing raw materials, manufacturing and packaging, use, operation during lifetime. So life cycle assessment, all right, would be disposal at the end of useful life. Which two processes are used to make ceramic plates? Forming a composite, galvanizing with zinc, heating in a furnace, melting, sand and boron trioxide, shaping wet clay. Since we are going to make ceramic plates, first we need to shape wet plates. Then we need to heat it in a furnace. Polypropylene is produced from an alkene. The name for very large molecules such as polypropylene is polymer, since this is a very large molecule made of monomer. The name of alkene used to produce polypropylene is monomer. Since they are asking the name of the alkene, so not the class of compound, that's why we have to answer propylene. The alkene needed to make polypropylene is produced from crude oil. Which two processes are used to produce the alkene from crude oil? From crude oil, first of all, we need fractional distillation to separate different fractions. Alright, once we do that, then we can do a particular process called cracking. Once we carry out the cracking, then we are going to get alkene. Name the type of bond that joins the atom in a molecule of polypropylene. This is an organic compound, and organic compounds are joined together by covalent. Table 4 shows the information about two polymers used to make plates. Polymer A does not melt effective heating on the polymer, and polymer B melts at 50 degrees Celsius. What type of polymer is polymer A? So polymer A is not affected by heating, alright? That means it is a thermosetting polymer. Why does polymer A behave differently to polymer B when heated? You should refer to crosslinks in your answer. Polymer A has crosslinks between the polymer molecules, whereas polymer B does not have crosslinks between the polymer molecules, which is why it melts at lower temperature. This question is about ethanol and ethanoic acid. Ethanol is an alcohol. Figure 7 shows the displayed structure formula of ethanol. You can see two carbons single covalently bonded. With other hydrogens, there are single covalent bond, and with oxygen, and then with the hydrogen. Draw a circle on figure 7 around the alcohol functional group. OH is the functional group of alcohol. An ethanol molecule contains atoms of 3 different elements. The name of each element, the symbol for each element, and the number of atoms for each element in one molecule of ethanol. O is oxygen. Hydrogen has a symbol of H. Carbon, number of atoms in one molecule of ethanol is 2. Ethanol removes grass stains from clothes. What type of substance is ethanol when used to remove grass stains? Ethanol is acting as a solvent. Wine contains ethanol. Wine is produced from grape juice by fermentation. Grape juice can be fermented to produce wine because grape juice contains sugar. When fermentation takes place, sugar converts into alcohol. What is added to grape juice to cause fermentation? So yeast is an fungi that contains enzyme to do fermentation. Ethanol reacts with ethanoic acid to produce an ester. What is the name of the ester produced when ethanol reacts with ethanoic acid? So when ethanol reacts with ethanoic acid, the ethanol becomes ethyl and ethanoic acid becomes ethanoate. So it becomes an ester. Ethanoic acid reacts with sodium carbonate. Ethanoic acid reaction with sodium carbonate, sodium ethanoate, water, and carbon dioxide. What is the name of the liquid produced by this reaction? The liquid is water. The L represents the liquid. Vinegar is a solution that contains ethanoic acid. 400 cm³ of vinegar contains 20 grams of ethanoic acid. Calculate the mass of ethanoic acid in 1 dm³ of vinegar. So 400 is equals to 0.4 dm³. Then what we're going to do is we're going to divide the 1 dm³ with 0.4. Then we're going to know the amount in relation with 0.4 dm³. How many 0.4 dm³ we have within 1 dm³? Then we're going to multiply that with 20 because 400 cm³ contains 20 grams of ethanoic acid. So we're going to multiply that and our answer will be 50 grams. This question is about chemical analysis. A student tested copper sulfate solution and calcium iodide solution using flame test. So the ions that we're going to be testing using flame test are cations, copper and calcium. The student used this method. Dip a metal wire in copper sulfate solution, put the metal wire in blue Bunsen burner flame, record the flame color produced, Repeat steps 1 to 3 using the same metal wire but using calcium iodide solution. What flame color is produced by copper sulfate solution? Copper sulfate solution contains copper 2 plus ion, and copper 2 plus ion, the flame test for copper 2 plus ion is green. It will produce green color. Calcium compounds produce an orange-red flame color. The student left out an important step before reusing the metal wire. The student's method did not produce a distinct orange-red flame color using calcium iodide solution. So basically, the student did not clean the metal wire between the test. Copper sulfur solution was still present in that metal wire, so the colors got blended once the student tested for calcium iodide. The student added sodium hydroxide solution to copper sulfur solution, calcium iodide solution. Sodium hydroxide with copper will give blue precipitate. Sodium hydroxide with calcium iodide solution will give white precipitate. To test for the sulfate ion, the student added diluhydrochloric acid to copper sulfur solution, named solution that would show the presence of sulfate ion in the mixture. Sulfate ion is tested with barium ions, and a soluble barium 2 plus ion will be. So in this case, the student can use barium chloride. To test for iodide ions, the student added dilunitric acid to calcium iodide solution, named the solution that would show the presence of iodide when added to the mixture. Give the result of the test. Iodide or halide ions are tested with silver ions, soluble silver ions. So in this case, the solution must be silver nitrate, and the result will be yellow precipitate. This question is about water. In UK, potable drinking water is produced from different sources of fresh water. Explain how potable water is produced from fresh water. First of all, the water is taken from an source. Example, river, streams, lakes, or from under the ground using boreholes. Then the water is passed through filter beds, which remove undissolved solids that are in the water, but we can't necessarily see them, but they are still in the water. There can be undissolved and there can be very small bits of silica, so those can be removed. Then the water is sterilized using chlorine, ozone, or ultraviolet light, which destroys the harmful microbes present in them, making the water safe to drink. A long coastline, plentiful energy supplies. Suggest one process this country could use to obtain most of the potable water. Well, since the country has a very long coastline and a lot of energy supplies, the country can go for either distillation because they do not have shortage of energy supplies, or they can go for reverse osmosis. Wastewater is not fit to drink. Treatment of wastewater produces two substances, liquid effluent, solid sewage sludge. Draw one line from each substance to the way the substance is processed. Liquid effluent. Liquid effluent is basically, it's like human waste and other things like that are dissolved in water. Since they contain nitrogen compounds, so aerobic biological treatment, aerobic bacteria would be a good solution to remove them. And then solid sewage sludge, we can do anaerobic digestion on them to produce methane and break them down. Table 6 shows information about the disposal of processed solid sewage sludge in the UK in 1992 and in 2010. So used as fertilizer, right, sent to landfill, burned, other methods, and in total 998, we get the values. Calculate the percentage of processed solid sewage sludge that was burned in 2010. Your answer must be given in three significant figures. So in 2010, all right, we can see 260 million kilograms of processed solid sewage sludge was burned. So 260 divided by the total for the year was 1413 times 100% gives us 18.4005%. Since we have to give the answer to three significant figures, so it will be 18.4. Suggest one reason why the total mass of processed solid sewage sludge increased between 1992 and 2010. Between 1992 and 2010, the population has increased. So more wastewater is produced and less untreated sewage is discharged directly into rivers and streams because of innovations of technologies. Now, you just have to write only one point. Between 1992 and 2010, the proportion of processed solid sewage sludge used as fertilizer increased. Such two reasons why. There is an increased demand for food due to increasing population. And, when solid sewage sludge is used as a fertilizer, this conserves energy, all right, from producing more fertilizer using fossil fuels. All right. And also, dumping solid sewage waste requires landfill space, which we are totally running out of. All right. And then there is an increased demand for organic fertilizer, which also requires a fertilizer that comes from natural sources. Hexane and hexane are hydrocarbons containing 6 carbon atoms in each molecule. Hexane is an alkane and hexane is an alkene. Draw one line from each hydrocarbon to the formula of the hydrocarbon. So hexane. Hexane is an alkane. So alkane has a general formula of CnH2n plus 2. And since it has 6 carbons, so there will be 14 hydrogens. Hexene. Hexene is an alkene which has a general formula of CnH2n. So C6 will give H12. Bromine water is added to hexane and to hexene. What would be observed when bromine water is added to hexane and to hexene? When bromine water added to hexane, the bromine water, the color remains orange. It doesn't disappear. However, in hexene, when bromine water is added, the initial color, orange, changes to colorless. Ethane is an alkane and ethene is an alkene. Figure 8 shows the displayed structural formula of ethane and ethene. We can see ethane is an alkane with CC single bond. Ethene with CC double bond is an alkene. Compare ethane with ethene. We should refer to their structure and bonding and their reactions. So both ethane and ethene are hydrocarbons. They contain 2 carbon atoms per molecule. Ethane contains 6 hydrogen atoms per molecule, whereas ethene contains 4 hydrogen atoms per molecule. Both have covalent bonds. Ethane contains a single CC carbon bond, whereas ethene contains a double bond between the carbon and carbon. Both contain CH bonds, and both of them are small molecules. In terms of the reaction, both react with oxygen in complete combustion to produce water and carbon dioxide, and both react with oxygen in incomplete combustion reaction to produce water, carbon monoxide, and some carbon as soot material. Incomplete combustion is more likely to happen with ethene. Ethene decolorizes bromine water, but ethene does not decolorize bromine water. Ethene is more reactive than ethane because it contains the carbon-carbon double bond. Ethene can react with hydrogen to produce ethene. Ethene can react with water to produce ethanol. Ethene can react with halogens to produce halogen alkenes. Ethene can undergo addition reaction. Ethene can polymerize to produce polyethylene. All of these are valid answers. Since we only have to write for 6 marking points, so it is better to write 3 structure and bonding points and 3 points for reaction. So guys, that's all for today's question paper. Thank you for watching the video. See you in the next video.